So when we start looking at the caloric demand, say by 2050, there's going to be almost 70% more demand for crops. At the same time, we have water shortage. The arable land is reducing. Over time, there's a lot of pressure to make sure that there's food security there for this growing population. How do we get to that point? The only way to get to that is using controlled environment agriculture. That's basically greenhouses. Even they are dependent a lot on labor. They are a lot more optimized in terms of their automation in different areas. It's high density, they have a lot more crop and a lot less water usage. They need something where there's a scalable system that has high uptime, high reliability, it's robust enough to work in this environment.
Harvesting fresh produce is one of the most challenging things to automate because it requires a human-level understanding on the vision, the ability to move through space in dense scenes to the proper location, and being able to then pick the product without damaging it. At For Growers, we've solved this because we've developed our own proprietary AI models combined with our patented hardware that enables us to pick tomatoes faster than even people can on our best harvests.
The GR200 robots is our primary or flagship product. We have a harvesting cart and then we have a packing cart. The harvesting cart has industrial arms, so we use a 6 degrees of freedom FANUC industrial arm. It has a vision and the perception system that takes the pictures of the tomatoes, the plants, environment. It is self-driven, it goes on rails in the greenhouses. And it also has a compute module both for our perception as well as the Beckhoff and other control systems there. And then behind that, we tow a packing cart. The user pushes it into the row, they press a button, ready to go. The system gradually moves itself, it takes a picture, it analyzes what are the right crops, where the crops are, how to get to that point, thinks about the motion planning or where should the arm go there, and we use vacuum suction to both harvest the tomatoes and transport it. We have to get to a point that it's a system that works reliably every single time. It's scalable, it's manufacturable, it is available whenever it's needed. We have a fleet out there that's a reliable system that's commercially available. We also have the fastest harvesting robots that's commercially available in the world right now.
What we've seen to be the biggest unlock for growers who might be skeptical about automation is just seeing it live. When you see the robot work and harvest entire rows continuously, you know that this isn't a science project. It's a real product that works.
The way we connect industrial automation to agriculture in the greenhouse is it's a hot, humid environment, so we have to select components that meet these harsh environments. So I selected the embedded PC, all the I/O, all the twin-safe logic modules, and the compact drive technology, and they basically drive all our auxiliary axes. We don't have the luxury of a typical industrial automation where you have huge control cabinets, so we need to use compact technology to be able to make that happen. We have 3 major safety areas. We have safety buttons, we have the e-stops, and we have the safety laser scanners. We wired them all back up to a Beckhoff safety module, and in that safety module, we handle all the I/O, this twin-safe logic and everything.
We need a partner that is going to help us scale. That's going to help us, that's something that's reliable and ruggedized for this environment, right? These are something that's expected to work in the field for, say, 5 years or 10 years. The biggest things that stood out was from a service perspective, from a temperature range perspective, from a technical documentation perspective, and the safety perspective. And when we went through this evaluation, it was clear that Beckhoff would be the partner who can help us scale and get us to the next level. But they were kind of the one who were coming and asking the right questions where, does this make sense to use to combine multiple I/O modules? Do you start splitting? Is there a different opportunity for cost reduction, which is similar performance, or is there kind of a different arrangement of parts that makes sense? Physical tangibility to hardware design where it's not one day it was in the CAD model in the computer, somebody was just turning it around. Now it's just out there in the field, working, picking millions of these tomatoes. And we are seeing that feedback of every design decision that we made playing out in a way like, hey, that worked, that was really good, or this is an opportunity for it to learn. So that tangible impact on the real world and trying to solve real customers, it's a very exciting feeling to have.